all space station systems operating well at this time, and the crew working smoothly through their activities. We bring you again live video from Kennedy Space Center, where, as you can see, Space Shuttle Discovery has just made an appearance out of the orbiter processor facility. It's being backed out at a slow and delicate pace here to reposition it to bring it into the vehicle assembly building. You can see in this view the key support personnel staged at various locations helping to oversee this delicate work as the vehicle is being gently backed out. And also towards the back of your screen, other personnel just observing this milestone activity for the STS-121 mission.
And Huntsville Station, Space to Ground 2. I'm not sure I understand the intent of step 4.7, nor can I locate getting 2 syringes.
This is Mission Control Houston, bringing you live video from the Kennedy Space Center with the Space Shuttle Discovery, which has just been moved out from the orbiter processing facility and now being moved in the direction of the vehicle assembly building, which will be its next home as it is readied for its upcoming mission in July, that being the STS-121 mission, which will be commanded by astronaut Steve Lindsay. Lindsay flew as a pilot on STS-87 in 1997 and STS-95 in 1998, and was the commander on STS-104 in 2001. He'll be assisted on that mission by pilot Mark Kelly. You can see now the vehicle as it's making its approach to the Vehicle Assembly Building located at the Kennedy Space Center, where it will go through the next stages for its preparation for the mission later this summer. You can see in this view the growing crowd there at the Kennedy Space Center at the fence line observing this activity as the vehicle is being transported to the Vehicle Assembly Building. Discovery, also known as OV-103, is the third of NASA's fleet of reusable spaceships. It arrived at the Kennedy Space Center in November 1983 and launched on its first mission on August 30th, 1984. Discovery is named for two famous sailing ships, one sailed by Henry Hudson in 1610 to search for a northwest passage between the Atlantic and Pacific Oceans, and the other by James Cook on a voyage during which he discovered the Hawaiian Islands. This is Mission Control Houston. We're continuing with live coverage from the Kennedy Space Center as you're watching Space Shuttle Discovery on its path from the Orbiter Processing Facility, making its way to the Vehicle Assembly Building. This activity, a key milestone in its preparation for its upcoming mission, STS-121, scheduled for July of this year. Once in the vehicle assembly building, the space shuttle will be attached to a special crane, and that will position it in a vertical position and maneuver it close to the engine tank and solid rocket boosters, which are already in a position ready to be mated to the vehicle.
Two or three times.
It's a different view of that space shuttle vehicle activity at the Kennedy Space Center. It's just taken from a different vantage point, but again, coverage of the Space Shuttle Discovery as it's being relocated from the orbiter processing facility and making its way to the vehicle assembly building. All of that activity going smoothly. Activity beginning just about 30 minutes ago, and in this view you can see some of the key support personnel overseeing that activity, this delicate operation of moving the vehicle, and just some interested observers at Kennedy Space Center for this milestone event for NASA's next space shuttle mission. So in this view you can see the entrance to the vehicle assembly building from which the orbiter will be entering. The vehicle assembly building is one of the largest buildings in the world. It was originally built for assembly of the Apollo Saturn vehicles and was later modified to support the space shuttle operations. The external tank and the solid rocket boosters are already located in the vehicle assembly building, and they're already put in position with each other, just awaiting their space shuttle vehicle, which will launch them into space again in July. The vehicle assembly building covers 8 acres. It's more than 500 feet tall and 716 feet long. It encloses more than 100 million cubic feet of space. During the space shuttle buildup operations inside the vehicle assembly building, integrated solid rocket booster segments are transferred from the nearby assembly and checkout facilities. They're then hoisted onto a mobile launcher platform in high bays and mated together to form 2 complete SRBs. The external tank, after arrival by the barge, is inspected and checked out in high bays as well, and then transferred to a different high bay to be attached to the solid rocket boosters already in place. The orbiter is then moved again from the orbiter processing facility to the VAB transfer aisle, which is the activity we're seeing now, and raised to a vertical position, then lowered onto the mobile launcher platform and then mated to the rest of the stack. When assembly and checkout is complete, the crawler transporter enters the high bay, picks up the platform and assembled shuttle vehicle, and carries them to the launch pad. We will continue with Space Station, or this commentary hour, to bring you this coverage of the Space Shuttle Discovery's milestone, moving from the processing facility to the VAB. We'll return with regular NASA programming as soon as this activity is complete. This is a different view of the Space Shuttle Discovery as it's being maneuvered to enter the vehicle assembly building located at Kennedy Space Center. This is a vantage point from inside the vehicle assembly building where the space shuttle will be entered and repositioned to be mated with the external tank and solid rocket boosters already in place. This activity a key milestone in preparation for the next mission for Discovery, STS-121. The crew of Space Shuttle Discovery will continue to test new equipment and procedures that increase the safety of space shuttles. We'll also perform maintenance on the space station and deliver more supplies and cargo for the future station expansion. Discovery will also be bringing a third crew member to the space station, European Space Agency astronaut Thomas Ryder. This will be the first three-person crew since Expedition 6 crew returned to Earth May 4th in 2003. Discovery will also carry the Italian-built multi-purpose logistics module, Leonardo, with more than 2 tons of equipment and supplies on board for delivery to the space station. This will be the 4th trip to the station for Leonardo, the first of 3 Italian-built MPLMs. Likewise, equipment and supplies no longer needed on the station will be moved to Leonardo before its unberth and put back into Discovery's cargo bay. At this time, the Leonardo logistics module is inside the space station processing facility, also at Kennedy Space Center, in its final closeout operations and preparation for its mission. Astronaut Steve Lindsay will be the commander for the mission, and he'll be assisted by astronaut Mark Kelly, serving as the pilot for STS-121. In addition to Thomas Ryder, others along for the mission will be Mission Specialist Mike Fossum, Stephanie Wilson, Pierce Sellers, and Lisa Nowak. This will be the first mission for all of them except for Sellers, who's making his second space flight. Ryder again will remain on the station, working with the station crew under a contract between ESA and the Russian Federal Space Agency. As you can see in this view, the vehicle itself being transported and that operation going smoothly as it's making its entrance into the vehicle assembly building, appearing just past halfway through in the vehicle assembly building, which for comparison purposes is about 200 feet taller than the Statue of Liberty. Once inside, the vehicle will be attached to a special crane that will rotate it into a vertical position and put it in position to be mated with the external tank and solid rocket boosters already in place there. This is continuing live coverage of the Space Shuttle Discovery located at Kennedy Space Center, which is just nearing the end of the activity, transporting that vehicle from the orbiter processing facility and moving it into the vehicle assembly building, which you're seeing here. This camera view from the interior of that building as the Space Shuttle has just entered a few moments ago and slowing down a bit as they make this delicate entrance into the vehicle, into the building. This movement activity started just about 1 hour ago. This is just one of the key processing milestones for the vehicle as it prepares for its upcoming mission. And you're seeing the final views of Space Shuttle Discovery as it's entering the vehicle assembly building, just completing its transport from the orbiter processing facility, located very close proximity to this building, but out of view. That activity lasting just about an hour as it commenced just after 9 a.m. Central Time. Excuse me, 10 a.m. Central Time, and making its way to the vehicle assembly building, where at this point it will be attached to a special crane and put in position for mating to the external tank and solid rocket boosters already in place in that building. At this point, we will conclude today's commentary hour. We leave you with the International Space Station Expedition 13 crew in their 44th day in space, and all activities going well in their crew day.
Now the tires are the right fraction this time, right? Yeah. One more minute, then we'll look up. somebody checking to go see what that was? There's a guy on a parachute. Really? Yeah. Oh, yeah. It just came down.
Wind tunnel tests are basically complete. The aerodynamicists have taken the wind tunnel test data and they have turned it into loads data that the structural engineers are now poring over. All of the preliminary loads indication, and we're talking about the power ramp removal here on the external tank, all the preliminary loads indications are good, but we have to wait until they get to the bottom line. You don't know till you add up the last column of numbers, and that's going to come in just before the design certification review for the external tank. Coming up here in about 2 weeks. Well, you know, it's kind of like doing your taxes. The first time through, you kind of do a rough cut, and you see whether you're going to get a refund or not. If you get a refund, you get real excited, and it makes you work. And if you're not getting a refund, you kind of put it off till April, whatever. That's what we've got from the structural guys. They've got their first rough cut. It looks good, but you really don't know what you got till you work through the entire analysis and look at all the cases. There's something like 34,000 loads cases that they have got to look at, and the job's not done till it's done. We're very hopeful, and I feel a good degree of confidence it'll all come out good. Else we wouldn't have rolled the vehicle out here today. But you can't say it's done till
Welcome to the Kennedy Space Center for our next Space Shuttle program update. We have with us today Wayne Hale, who is the Space Shuttle Program Manager, and Mike Leinbach, who is the NASA Launch Director. And we'll begin with opening statements from each of these. Wayne?
Well, good afternoon. It's always good to be in Florida, and it's a great day when we can come down to the Kennedy Space Center and see the Space Shuttle sitting on a launch pad. You know, the preparation for a shuttle launch is an intensely technological thing, but it's also a supremely human thing. We have had so many people work so very many long hours to get to this point to have Discovery on the launch pad. Thinking about the folks at Michoud Assembly Facility who have worked as extremely hard in very difficult circumstances to provide the external tank. All of the folks here in Florida that have assembled the stack, the solid rocket boosters, and on and on and on through the mating and the rollout that we had about a week ago. It has just been a great period of time. Today we gathered at the Kennedy Space Center with a large team from all around the agency of folks supporting the shuttle program to do another one of what sometimes seems to be an interminable round of reviews to make sure we're ready to go fly. Today's review was a debris verification review. This review is something that is new with return to flight following the Columbia accident. We feel a very strong need to review how well we have done in eliminating the potential for debris to come off the external tank or any other part of the launch vehicle and cause a hazard during the ascent phase of flight. I'm pleased to announce that we have gone through that review and we have found no showstoppers. We believe we have made significant improvements since last year in the elimination of many of the hazards from foam. But one of the things I don't want to hear when I go home and turn on my TV tonight is that we fixed the tank and no foam is going to come off, because that is not the case. And you're going to hear me say this over and over again as we go down to flight. There will continue to be foam come off the external tank. What we have done in a very systematic manner is eliminate the largest hazards. Today we have a tank on the pad that has lost 34 pounds, the largest amount of foam off the tank that we've ever taken off the tank to reduce the hazard. We have put on a special set of sensors, both accelerometers and force measurements on that tank, as well as a suite of 6 new cameras on the solid rocket boosters that will be monitoring the performance of the vehicle during ascent to ensure that we have done our job properly in the removal of that protuberance airload ramp, the reduction of foam. But we do expect to see foam come off. In particular, as we look today, the next largest source of hazard, the 34 brackets on the outside of the tank that hold the piping on the outside of the tank on are covered with 1.5 pounds to 2 pounds of foam each for another 30 or so pounds of foam. We know that next on our agenda for following tanks will be the elimination of that foam. We have a team in full court press in the design centers, both back at Marshall Space Flight Center as well as the Michoud external tank facility, working toward a design of that bracketry that will allow it to be flown without foam on it, will keep the ice from forming as well, but without that foam. And subsequent to that, we will work on the next area of concern and eliminate systematically, as we go forward in time, the sources of foam coming off the tank, so that the very last tank we fly, I think, will be the very safest tank that we'll ever fly, the one causing the least source of debris. Today, in our review, we did come to the conclusion that we have an acceptable risk posture to go fly from the debris standpoint. That is a major milestone. Next week, we'll be going to the external tank design certification review, and at that time, we will find out from the structural analysis whether all of the aerodynamic changes have resulted in a situation where the structure will still hold together. As I told you about a week and a half ago, our preliminary words are good, but we are going to find out the final story next Wednesday at that design certification review. And then in about another 10 days following that, back down here on the 16th and 17th of June, we will have the flight readiness review for the final management review of the preparations for the flight of STS-121. We're looking forward to a good flight at the opening of the window on July 1st. And with that, I'll hand it over to Mike.
Okay, thanks, Wayne. Well, as Wayne and his senior managers are going through their interminable reviews, we get to process the hardware here at the Kennedy Space Center, and I can tell you the hardware processing is going extremely well with the vehicle at the launch pad. Between now and launch on July the 1st, we have almost 2 weeks of contingency in the schedule. As long as I've been in this business, we've never had that amount of contingency. And we built in quite a bit this flow we were protecting for a tanking test, which we thought we might have to do. Turned out we do not have to do that tanking test. So that fell off our plate and saves about 5 days or so. So while it's an unusual pad flow with the amount of contingency we have, it's an understood pad flow. And so far everything's going really, really well. The crew will be here in about 2 weeks for their terminal countdown demonstration test. That's where we get the crew here and we get them into the orbiter. It's especially important for them to be here and go through the final preparations for launch. They get suited up and get into the vehicle. It's especially important for the rookies on the team. So we'll do that in about 2 weeks, and we'll be ready for the picking up launch countdown on the 28th of June. Meanwhile, over in the OPF, Orbiter Processing Facility, Atlantis' processing is going extremely well also. Looking for a rollout of Atlantis on July the 25th. That's on schedule. That would be for the STS-115 mission or the launch on need should a rescue mission become necessary. So right now we're in great shape on both vehicles and looking forward to launch on the 1st.
Okay, thanks, Mike. Okay, let's take some questions from Kennedy, then we'll go to other centers that I understand also have questions. So, Bill, you had your hand up right here, second row.
Bill Harlow with CBS for Wayne. I remember last year when you had the DVR, there was this risk matrix and where the foam fell out in terms of probable or unlikely, or how did that work out in this one? I heard there was a little bit of discussion about how to characterize ice frost ramp foam. Can you maybe give us a sense of how that stands?
We did go through the review today. We did not baseline the hazard report, which is where you see these little 3x4 matrix with the red, yellow, green squares in it. You know, we had a discussion about 2 weeks ago. It's been longer than that, 3 weeks ago, but we talked about ice frost ramps. We included the administrator and the chief engineer of the agency, chief safety officer of the agency, and went through all the pros and cons. At the final analysis, the agency concurred with my recommendation, which is that we not change those ice frost ramps. We think they are a hazard. I want to make that very clear. They are an area of foam insulation that we very definitely need to deal with. The principle that we have to remember, however, is that in flight test you want to make one major change at a time, instrument it, fly it, and see how that performs before you make another major change. So we are going to fly this flight with a major improvement, the elimination of the PAL ramp, but we know that we have another hazard that we also need to eliminate, and that will be the elimination of the ice frost ramps as quickly as we can come up with a good design option that will eliminate that hazard. So we put them right at the top of our risk matrix. That's the number one thing that we have to work on next. We have a whole list, I wish I'd have kept count, of lower risk but still areas in the tank that we want to continue to work on. We've tried to characterize all of those things over the last 2 days and put them in the right place in the hazard matrix.
But you didn't have to assign a probability.
Well, you know, it's an interesting thing. I wish I'd have taken probability in college. We have discussed probability more in the last 48 hours than I ever really wanted to. And the bottom thing that you come to with the probability is, what were your assumptions? We've looked at the flight history, and if you look at the flight history, we probably don't have much risk. We looked at the causes for the so-called thermal crack
cause for foam loss, which caused that big piece of foam to come off the power ramp on STS-114. And we tried to apply that to the ice frost ramps, and we don't see nearly as many losses off the ice frost ramps from our flight history as the empirical or physics-based model would indicate. So you run all these things together, you try to decide how many releases there may be on a flight, and you come up with different numbers based on different assumptions. Basically, this vehicle, and you can take this to the bank, is about a 1 in 100 vehicle, okay? That's not a scientific number. If you want a scientific number, it's probably a little different than that, but you know, it is a risky vehicle to fly. And nobody should mistake that. There are a number of things that can cause bad outcomes in this vehicle. What we've tried to do is take a very serious look at every one of the areas that we think are high risk and do our best to mitigate those and reduce the risk. So did that answer your question, or did I just? Okay.
All right. Let's go to Mike Cabbage.
Mike Cabbage with the Orlando Sentinel for Wayne. Is the DVR going to be a standard thing for every shuttle launch from here on out? And when did you come up with the idea of doing a DVR for this mission? Was it after the shedding that you saw on Discovery last July, or is this something that is just going to happen from here on out?
You know, I think we're probably going to have debris verification reviews periodically. I don't know whether we'll do them on a per mission basis. Obviously, following the loss of Columbia from debris, we needed to have a review before STS-114 of how well we had done. Since on our first flight, STS-114, we had another unexpected foam loss, we felt the compelling need to have another review to see if we had improved ourselves adequately to launch this time. We have a number of things that we want to improve in the future. Based on what performance we see out of STS-121, we may or may not have a debris verification review before the next flight, which, after all, comes only about 8 weeks, a little less, later. But we certainly will have a debris verification review when we make the next big change, which would be the ice frost ramps. So we will have them periodically, but probably not every flight.
Follow-up question to that. Looking at the schedule and the way it's unfolding right now, what's your best guess on when you guys might be ready to fly modified ice frost ramps?
I'm going to hear a story on that in the next few days. The next tank that's coming out from the factory from Shuttle is also coming with unmodified ice frost ramps because currently we don't have a good redesign. The folks are working on that. Whether we can get that on the third tank or the fourth tank is probably the real question. And we are looking very hard to getting a design into the wind tunnels that we can verify will not shed additional pieces or cause other problems. We've got a series of thermal cryo tests to show that whatever modifications we do will not go ice, which, by the way, is why they have that foam insulation on them. We probably are going to have an interim solution based on what I have seen with some insulators in between the upper and lower parts of the bracketry, followed by a final solution, we think. And again, this is the early thoughts of the design team. The final solution may be to make the entire bracket out of a very low conductivity material. Titanium is a high strength, low thermal conductivity material that's been identified. That final solution probably won't come along for several more tanks, maybe 6 or 8 tanks. So we're probably going to see an interim reduction in most of the foam with a final solution of complete elimination of the foam around these brackets coming 6 or 8 tanks down the road.
Okay, let's bring the microphone back over here and go to Jay Barbary, down the aisle, third row.
Jay Barbary with NBC. Wayne, I asked you about this the other day at the rollout. You're talking about the ice frost ramps, and you get better pictures, I understand, the second, third, or fourth. You're going to visit that on the status 2-week meeting. How are you leaning? Are you leaning toward going ahead and flying if everything is ready, if you have no problems, weather is good, all on the first? Are you leaning to go with what you have at that time, or do you feel that the lighting that you will get on the ice frost ramps will be more important to take a chance to go farther into the window?
Good question, Jay. We've had our photo analyst folks looking at the lighting on a day-by-day basis. One of the big inputs to that analysis is the exact orientation of the tank. And as you know, when we separate the shuttle from the external tank, the tank is uncontrolled at that point. And it generally has what we call small tip-off rates, or a little bit of roll, a little bit of pitch rate. And the lighting can vary quite a lot based on those very small angular rates that occur right after separation. Based on what we know today, there's no reason not to launch on July the 1st. That is not an absolute guarantee on any day, quite frankly, in the window, that you might not have some shadows due to these tip-off rates, but we think that the lighting's adequate on July the 1st. We're going to continue to review that data because the exact position you're in depends on where the International Space Station is, and as we get closer to launch, we'll get a better prediction of where the International Space Station is and exactly how that affects the launch window and the lighting. So it is possible we might move a day or so, but right now I don't think that's going to happen.
Weather and all of that, your inclination is to launch.
Yes.
Thank you.
Okay, Todd, right here, second row.
Todd Halverson of Florida Today with two, if I could. Wayne, how many other areas of the tank still could shed critical debris, and what are they?
Oh gosh, I should have brought the whole list. We had a long list. You know, part of the probability game is we looked at every piece of foam on the tank, and there are some more than 300 manually applied areas of foam on the external tank, in addition to the robotically applied acreage foam. We tend to concentrate on those manual applications, but there also was a considerable discussion about that robotically applied acreage foam. In a lot of these areas, we have never seen foam come off in flight. So one might say, well, you shouldn't worry about it, or you don't need to worry about it. However, that was the position that we had earlier on in the program about concerning some of the releases that we now are very concerned about. So we don't take that as, just because we haven't seen it before, you're never going to see it, as a good way to fly. So when we did probabilities for a lot of these areas which we've never seen foam come off, the statistical guys assumed a foam release, and they assumed a foam release with a mass estimate that came from the external tank team, and they put it at the worst possible time and looked to see if it could transport down. When you do that kind of probability analysis, again, make some of these very severe assumptions, there are many areas on the tank that potentially could cause critical damage. Then you weight the whole analysis with, do we have an understanding of how foam comes off the tank? Yes, we think we know 4 different potential mechanisms for foam to come off the tank. They have different physical applications. Do any of these apply to one of the areas that could cause potentially bad things to happen if they come off? Well, if so, then we're more worried about it. Does the flight history say that we've ever seen a piece come off in that area? Well, yes, then we're more worried about it. So you rack all these things together and you come up with a prioritized list of, I think, areas of potential improvement to eliminate the potential for debris release that's going to keep us busy for a long time. And that's why I say that we're on a road for continuous improvement. We're trying to take those in a priority order, eliminate the biggest hazards, and work our way on down. Let me give you an example. The foam that came off that brought down Columbia was about 1.6 pounds, over 1.5 pounds of The foam that came off STS-114 that made us stand down these many months to eliminate that hazard was about a 1-pound piece of foam. Now, the largest piece of foam that we've ever seen come off an ice frost ramp is 0.09 pounds of foam. Since potentially that's not the biggest piece that can come off, the statistical boys did an analysis for us, and they said you ought to consider that an ice frost ramp would lose up to 0.2 pounds of foam. So that's what, 2 or 3 times bigger. So if you think about it, 0.2 pounds is 3 ounces. Okay, costs you less than $1 to mail that letter down at the post office. So we are working our way down the list of potential debris sources to smaller and smaller releases. And we're also looking at the areas where we think they're more likely to release and working our way down the list to the areas where they're least likely to release. So over time, we will continue to see foam come off the tank, but they will be smaller and smaller pieces, and they will be less and less frequent, and therefore the risk and the hazard goes down. And that's the approach we've got to take.
A quick follow, I was curious about your rationale for flying with the ice frost ramps. I think it was STS-112 where you had a foam loss from the bipod that was fairly significant, and the approach at that time was to incrementally and serially attack the problem before you actually had a fix in place, and of course STS-107 came along. What is different now that makes you feel comfortable with the philosophical approach you're taking now with fixing it down the line instead of now?
Okay, well, you know, if we had not, okay, let me go one more time. If we had not had to address the PAL ramp, which was a much larger hazard, then we probably would be working on the ice frost ramp. But again, the principle here is in a flight test vehicle where you make a major aerodynamic change, the removal of the PAL ramp is the largest aerodynamic change we've made to the shuttle stack since we started flying it. The principle is make one change at a time. We addressed our biggest hazard, we have removed it, we have provided instrumentation in the cable tray to look at the aerodynamic forces on the brackets after we removed the PAL ramp. We've added cameras to look at how the tank is going to perform. We put all this instrumentation on it. We need to fly this vehicle to make sure that we did the first change right, the PAL ramp change, and then we can go address subsequent changes. Now, the other difference, I think, between now and then is then we had no idea why foam was coming off the tank, and now we have several years of very hard work in the laboratory and with the tank that we brought down here and tanked twice, took back to the factory, and have literally dissected the foam on that tank to understand the mechanisms for foam to come off the tank. We have a much better understanding of the mechanisms for foam release. We were in the dark then. We may not be perfectly in the light now, but we certainly know a whole lot more than we did and can make a much better educated estimate of our risk than we did then.
Okay, let's take a couple more questions here, then we're going to go to some other centers. Stefano?
Stefano Cordan, Time Magazine and Popular Science. I have 2 quick questions. I heard that there are potential electrical problems in one or both boosters. So this is a question for, I assume, Mr. Weinbach. And for Mr. Hill, what is the material that the conduit, the electrical conduit coming down the tank is made of? What's the material?
The actual electrical conductor, the cable tray. Okay, I'm sorry, we switched gears. I was about to give you the cable tray on the solid rocket boosters, which is aluminum. Cable tray on the external tank is aluminum, but it's covered with what they call super lightweight ablator slaw insulation to keep it from overheating and hold it together during the reentry of the tank to a certain altitude.
Okay, and on the electrical problem with the solid rocket booster, it's only on the left-hand side. I would characterize it as a minor problem at this point in time. It's a standard problem report that we pick up during processing. What we saw was a switch from one of our 3 main buses, the power feeds to the booster itself. Friday night switch from bus B to bus C. Internal to the integrated electronics assembly, there's logic that protects against faults, and so the box worked exactly as it should. Switch to the backup bus, and we're out there troubleshooting right now. The guys literally are at the pad right now troubleshooting the problem. I don't see this as a big issue at all. It's a problem report. We'll have it resolved as soon as we can. We're holding it as a constraint to booster power up because we don't want to power up the solid rocket booster with an unknown electrical problem. So it's to me, it's a standard processing issue that we'll work our way through. It's no big deal.
Okay, thanks. Let's take one more question from Mike, and then we'll go to headquarters for some questions there.
Hi, Mike Schneider, Associated Press. I was just wondering if you could go into a few more details about the debris verification review meetings, like how many people talked, how many presentations there were, and were there any dissenting voices who disagreed that the risk was acceptable?
Well, I'm pleased to report that we have a lot of dissenting voices. We had a very, contentious is not the right word, spirited may be the right word, discussion. I think that Ralph Rowe of the NASA Engineering and Safety Center provided us a lot of very good thoughts. We had a number of folks that were interested in making sure we had good rationale at every step along the way. This review, I'm trying to think, it's in our new building over here, the OSB-2, a beautiful place to have a meeting. We probably had over 100 engineers from around the agency here today that have been working in a variety of areas from the Kennedy Space Center, Marshall Space Flight Center, Johnson Space Center, folks from Langley and other places around the agency. I know we had some headquarters folks. So we had a quite eclectic group that was very interested in getting down to the nitty-gritty details of the engineering. It's interesting to me that engineers, as averse to the English language as they are, were very concerned about the exact words that we put in the report to make sure we captured our concerns and testing and results properly. So it was quite an exciting time for the last 2 days.
Okay, thank you. And I do understand we have questions at headquarters. So at this time, let's transition to headquarters. Take your questions, please.
Warren Leary, New York Times for Wayne. You mentioned that the continued work on modifications for the ice frost ramps. Does this mean you're going to have a lot more wind tunnel testing? How much more, and where will it be done?
Good question. Yes, we will be testing new proposed changes to ice frost ramp brackets and any residual foam that's needed around those brackets. I would expect that work will take place in probably the Glenn Research Center tunnels, as well as probably the Arnold Engineering tunnels up at Tullahoma. There's a potential we may do some of that work at the Ames Research Center as well. The wind tunnels around the agency have been used quite extensively in this pursuit of improving the external tank. I expect we will continue to use them extensively. And it will probably be multiple tunnels looking at different aspects of the design. There are even a couple of small tunnels, well, not small tunnels, but a couple of tunnels at Langley, as well as what they call the hot gas facility at Marshall that will be involved in doing testing. That's in addition to what we call the cryogenic testing, which is not a wind tunnel, but it demonstrates how well our design does in not forming ice, in other words, insulating from the cryogenic fluid inside the tank to this metal bracketry that hangs out in this nice, warm, humid Florida air that we have down here.
Tracy Watson, USA Today, and forgive me if you covered this in the first few minutes. I was a little bit late. Can you remind me which part of the TPS is of concern for foam from the ice frost ramps? Is it RCC? Is it tile? And also, Mr. Hale, if you wouldn't mind, I would love to get the range of estimates of probable damage from those ice frost ramps. You said that the numbers depend on the assumptions, and if you could tell me what kind of range you came up with, that would be great. Thanks.
Okay, let me see. The principal area of concern is with tile damage. We looked at the size of the releases that come off the ice frost ramp and the debris transport, that is to say the aerodynamics, and they don't pose much of a threat, if any, to the reinforced carbon-carbon wing leading edge. The tile, however, further back on the vehicle, and depending on which ice frost ramp you're concerned about, can be damaged in ways that might require a repair or certainly would not allow it to have a full capability for entry. Again, we're very conservative on that. If you get a certain size damage for the purposes of this review, we call it unacceptable. Whether or not, in fact, we could fly home with that is the subject of a really intense set of analysis that would have to be done. In terms of the numbers, I've been through so many numbers in the last day and a half, I'm having trouble remembering the number that sticks in my head. There are a couple of numbers that stick in my head, and I hope I've got these for the right case. With the very worst case assumptions, there were some numbers down as low as 1 in 75, and for some of the better case assumptions, we're talking about numbers on the order of 1 in 400 for ice frost ramp foam losses potential. But I think all of those, and I hope I'm not saying this wrong, because again, we've been through so many numbers and I didn't bring the whole package with me. Some of those assumed we had a release, which is not always the case, as you know. So again, I hate to quote probability numbers without the context, because it depends so much on what the assumptions were and how conservative or how fine the calculations were that went into the case. But we're talking, basically, I don't want to throw out a whole bunch of numbers, but we're talking basically something in the order of 1 in a few hundred or 1 in 100, which is consistent with the entire overall risk we fly with the Space Shuttle.
Okay, thank you. I understand we've got questions now from Johnson Space Center, so let's take those questions at this time.
Thanks, Mark Carreau from the Houston Chronicle. I have a couple of questions, and they're both for Wayne Hale, and I'll go one at a time. Tell us what you expect to see in terms of launch debris. I mean, if you can sort of spin this into a positive, an affirmative description, do you expect to see less debris overall than you saw in 114, or simply smaller pieces but the same amount of debris?
Well, we expect absolutely to see less debris than we saw in 114. In terms of we've eliminated the PAL ramp, so I don't expect to see any 1-pound pieces of foam coming off. I would expect to see foam losses in the less than a 1/10 pound range, several of those. We saw about 4 on the feed line camera that we had on STS-114. Given that we'll have now 7 cameras instead of the 1, I expect we might see 7 times as many in that small range. When we look at the photography that's taken post-external tank separation, and that's kind of the final analysis, how did that tank do all the way through the launch phase, we can see hundreds, and I'm not off base here, it's hundreds of little white splotches, and whether that means what we call popcorn or a little bit of foam that eroded away that is clearly not a hazard, or whether it's something that we would call a debris release, we're going to see a lot more of that on these cameras. That doesn't mean that our hazard is worse. That just means we're going to have a better view of it. So I expect that we will see, on the order of a dozen, I'll go out on a limb here, small less than 1/10 of a pound pieces of foam come off. Those will probably be very visible in the cameras that we'll get. You know, most of these, we'll still get the one live camera view from the liquid oxygen line camera. The other 6 cameras on the solid rocket boosters, they have to get the boosters back in port and pull the recorder out, and we'll release those about 4 days after launch, 3 or 4 days after launch. So I expect we'll see quite a lot, and no one should go home saying that, you know, we're not going to see any foam come off the tank. We've seen popcorn come off the intertank region quite a bit, and that we have done. We expect that'll continue to happen, and we do expect to see small pieces come off the ice frost ramp. I would be very surprised to see a large piece, and that's kind of the purpose of this test flight, is to see what we've got.
I had a follow-up question. Is there a point in terms of mission elapsed time into the liftoff where you're really in a vacuum, you're out of the impact sort of danger point, and at what point do you calculate that to be, if you have that?
Well, you know, interestingly enough, Mark, we had a long discussion about that today. Going into STS-114, we had said that 2 minutes and 15 seconds, 135 seconds into flight, was the end of the period at which we were concerned about aerodynamic transport. That the air pressure at that stage is you're up about 200,000 feet. There isn't much air up there. Our analysis folks went off and said, well, if you released a 1 pound piece of foam, when would you no longer have enough air to worry about it causing a collision hazard with the orbiter? And they came up with 166 seconds. My discussion with them, or the discussion that occurred today, is we really don't expect to see a 1 pound piece of foam come off. If we did, I would be worried about it any time. So I'm still stuck on 135 seconds, although the engineering analysts are trying to talk us into 166 seconds. And I don't remember the exact air pressure at 166 seconds, but I do remember saying it was 4 times lower than the almost nothing that you've got at 200,000 feet. So that's a considerably lower air pressure than you probably have in Houston today, Mark.
Gina Sinceri, ABC News from Wayne. Wayne, you said there are no showstoppers, but what are the hurdles that are still ahead before we reach July 1st?
Well, let's see, we've got a number of processing things, and I'm sure Mike could give you a long list. We're going to load the hypergolic propellants for the reaction control system. There's still a number of electrical checks and vehicle checkouts to do. So, I mean, there's a list. There is a standard list of those kind of things that all have to work properly before we go to launch. In terms of the management reviews, again, I would say the big items is the what we call the design certification review for the external tank that we're going to have next Wednesday. Actually, that's the final management summary next Wednesday. It's already started, and the important step there is to verify that the structural analysis folks can demonstrate with the new aerodynamic loads that the structure of the tank still maintains its safety margins and is safe to fly. That is a must-pass thing. There are other items at the design certification review that we're going to look at very carefully that could cause problems if the analysis and engineering review is not as we expect it to be. Then we have the flight readiness review, where we go over all of the things that have transpired, all of the anomalies that have been opened since last we flew, including those that occurred during flight, to make sure that we have done all our work properly. The design, testing, the construction of the particular piece parts on this vehicle, and new things we have done on the orbiter, the changes we've made there, everything from windows on down. All of those reviews have to go properly. Again, I foresee no showstoppers, but there is a lot of work that's got to be done in the next month to make sure that we're safe to go flying.
Okay, thank you. We do have some questions from Marshall, so let's go there next. We'll wrap them up. Okay, not hearing anything from Marshall. All right, should we go to questions from headquarters then? I think we have a couple of extra questions there, then we'll come back here to Kennedy. All right, well, I'll tell you what.
Guy Gugliotta from the Washington Post for either Wayne or Mike. So you have 2 weeks of contingency. Have you or could you reconsider having a tanking test? And if not, why not?
I'd be glad to take that one. We decided over a month ago, probably 6 weeks or so ago, not to do a tanking test. And so at that time, we stopped all activities leading towards a tanking test. We put the procedure development on hold. The team is not preparing for a tanking test. We have no requirements for one. So to do one now before launch is impossible, I would say. So we're not planning a tanking test anymore. There's no reason to do one.
Filling up the shuttle tank is not like running to your local gas station and hooking up the hose. It's a little more complicated.
Marshall, I'm the U.S. correspondent of the German daily Der Tagesspiegel. I'm interested in the timetable for the launch of the Columbus Space Lab, which is the European part for IRSS. The Columbus launch is scheduled at the 7th or 8th flight from now for autumn 2007, and I would be interested how optimistic you are that you can keep to the timetable, because I understand that every setback in the Space Shuttle program would also affect the launch of the Columbus Space Lab and this 880 million European taxpayers euros.
I was extremely pleased to see the arrival of the carrier aircraft yesterday with the Columbus module. I think there's going to be a ceremony here Friday, welcoming it into the Space Shuttle Space Station processing facility. We're anxious to come to the day where we launch that magnificent laboratory to become part of the International Space Station. I personally am very optimistic we will launch the Columbus module on the date that you mentioned. We have looked out into the future of our production schedule for external tanks and other things that we need, like solid rocket motors. And barring any huge unforeseen problem, I see no reason why we'd not be able to launch that exactly as we've scheduled. There seems to be plenty of time to allow for the normal, I call them normal, the minor day-to-day kind of things that we run into. We have plenty of contingency. So I think that launch will proceed exactly as we have scheduled it.
Okay, thank you. I do think we're going to go back and try it Marshall one more time. So let's take the questions from Marshall, and then we'll come back to Kennedy.
Good afternoon, gentlemen. Liz Hurley, WASF in Huntsville. This question is for Mike. Mike, tell us, you said you've got guys out there on the launch pad trying to troubleshoot the booster problem right now. Give us a timeline on when you expect them to come to some resolution. Will it impact your timeline at all? And Wayne, tell us about your redesign on the ice pods as far as the Marshall Space Flight Engineers. You said you haven't gotten a good design yet. How far along are they with that redesign?
Okay, I'll go first. The guys are out there right now. Our plan says we will give them tonight to troubleshoot. They have some what we call breakout boxes on the electrical system to send very, very small current message signals through the system to try to isolate the fault wherever it may be. So we'll give them a couple of more shifts, maybe a day to do that. We do want to get into our hypergolic loading for the orbiter side, and that's planned to pick up tomorrow. And so if we can't isolate the problem tonight, we're going to probably decide to go into our hypergolic loading tomorrow on the orbiter. That's about a 2-day job. And during those 2 days, then the electrical guys from the booster side would be able to look at their data in more detail and try to come up with the follow-on troubleshooting plan that we would enact over the weekend. And so with the contingency we have, I really don't see this as an issue for us. We may rearrange a little bit of our schedule. As I say, it is a constraint to booster power up, SRB power up, and therefore we don't want to load the hypergolics on board the booster. But we have plenty of time to get into that later in the pad flow. So we may rearrange a little bit. I can't give you a timeline, not knowing what the problem is. I can't tell you how long it's going to take to fix, but trust me, the guys are out there, and we've got the best in the world working on it right now.
Let me talk about the redesign of the ice frost bracketry, or I should say the protuberance bracketry that are covered with the ice frost ramps for just a second. We have a really excellent team at the Marshall Space Flight Center who is working very diligently on that. We had a preliminary design, which we took in the wind tunnel about a month, 6 weeks ago. Unfortunately, that design did not stand up to the aerodynamic forces that those foam areas would see during launch, and they continued, despite repeated modifications, to shed small pieces of foam, exactly what we don't want to have happen in the wind tunnel. We are now shifted gears to designs that eliminate foam wherever possible by using other kinds of insulating materials in between the metal parts. And the folks there at Marshall have been working with their cryogenic facility to ensure that we can build a design that won't grow ice. When we have that design finalized, and I think they're very close, we will go back into the wind tunnels. Wind tunnels are difficult to schedule because there are a lot of competing folks that like to do their work or need to do their work in the few wind tunnels that this nation has. We're talking about supersonic wind tunnels. And so we are working our way back into that queue, and we expect to be back in the tunnels testing those new improved designs in the next 6 to 8 weeks. And following that, we will have a good, I presume, we'll have a good series of outcomes and have a good design that we can then go implement in the factory. So I'm very pleased with the hard work that's gone on in Huntsville, Alabama.
Okay, do we have more questions from Marshall?
Yes, Patricia McCarter with the Huntsville Times. Assuming all goes well with STS-121, do you still expect to have 3 shuttle launches this year?
I've got a very, very good answer to that, yes.
All right, well, that's the last question from Marshall, so let's bring it back here to Kennedy, and we'll take a handful more questions here. Let's, Irene, you haven't had a question yet. Let's go with you.
Thanks. Wayne, I'd like to know if you have some ballpark current return to flight cost.
Oh, you know, that's one I didn't come with. There's return to flight part 1, and now we've got return to flight part 2. Most of our return to flight part 2, which is STS-114 to the present, has been concentrated with the external tank, and as a matter of fact, we have had quite a large expenditure down in New Orleans with the factory from hurricane damage, and we would have to split all that out. So the short answer is I don't have a good cost estimate for you on all this redesign work because it's wrapped up in the hurricane response as well. But we will go do some research and see if we can't. That's a good question, and I should have had an answer for you, Irene.
And also related to that, what kind of flexibility do you have in budget and in schedule if you need a 3rd test flight or if something doesn't go exactly as planned on this mission?
In terms of a 3rd test flight, we've already said we'd like to get a 3rd flight in daylight conditions to make sure we still know what's going on with the foam. There really isn't a cost delta associated with the 3rd test flight. And the only schedule constraint is really the lighting. If we get ourselves off in August, September, or even into October, we have good lighting windows for that. So I really don't see much problem making, I hesitate to call it a third test flight, although that's effectively what it will be to see how well we've done on the phone. One of the things that we have yet ahead of us to talk about is when we roll out the new bracket design for the first time, the improvements to the ice frost ramp. Do we need to see those in daylight? And we haven't had that discussion yet to see how they perform. That's a discussion that we'll have ahead of us, and I think that may wind up being next spring.
Okay, let's see, let's take it to the front row right here. Try to get around to folks that haven't any question yet, then we'll go around to others.
Yes, Justin Revere, Talkline is just wondering, foam work aside, ice work aside, how would you characterize the work that's happened on the in-flight repair techniques, and how comfortable would you be in the event of, obviously it would have to be fairly minor damage, but being able to use what's going to be flying on this mission and be able to fly home on it?
You know, we've had really a full court press on in-flight repair. If you think about what the heat shield does, okay, first of all, it's got to weigh almost nothing because it's big, and every tile weighs a quarter pound, something like that. It's a very lightweight material. Mostly, it's nothing. You know, it's got a little bit of fiber and mostly nothing in between as an insulator, and it stands up to 2,500, 2,800 degrees for half an hour. There are not many materials in the world that can do that. So it's 2,800 degrees on one side and cool to the touch on the other side. You know, my oven doesn't even do that. So to say that we're going to now go out in the vacuum of space where it alternates between 250 degrees above zero to 250 degrees below zero on every 90 minutes, and there is no gravity to kind of get stuff into a depression or something. You know, it is almost impossible to think about repairing that material. I'm pleased to report that we have 4 repair techniques that have not certification level capability, but some good engineering basis in thinking that they will work. And we're putting forward work for improvements as well. So it's not a great capability. We've had people working on it very hard for the past 3.5 years, and they have really beaten the bushes and worked very, very, very hard to give us the maximum capability that you can get. We're going to continue to work on repair capability for the life of the shuttle program. And you know, in a way it's a little sad because this reusable surface insulation that we use in the orbiter, fabulous stuff, does not have a home in the future program. Someday, no doubt, we'll come back to reusable thermal protection systems, and the work we're doing today will pay off for that generation as well. But right now we're just working to get ourselves as much capability as we can have for the life of the shuttle program, and perhaps that'll lead to greater things later on as well.
Thank you. Jay?
Mike, the way things are right now, you're expecting rollout Atlantis on July 25th, have it ready for a August 28th launch. If you had to use it on a rescue mission, where you are now in the flow, say anything, if you had to go to the station or not to the station, you lose propulsion, any need, how fast could you get it off the ground on an emergency, on a rescue mission, if something goes wrong with this launch?
Yeah, it's a good question. Our processing flow in the OPF is really based on mission processing. And it turns out that the capability the International Space Station has to support our crew in the event of a rescue says that we can stay on that processing schedule in the OPF. We can roll out on July the 25th, whether it's for STS-115 or for a rescue mission. So our plan in the OPF on paper right now doesn't change. If we did run into a problem with the launch of STS-121, we would very much look at our processing flow in the OPF and see if we could speed it up. The capability on the International Space Station says we don't have to do that. So we would probably stay on the same schedule, get out to the launch pad per plan on August 1st. But then our pad flow changes. We would launch in about 18 days for the rescue mission as opposed to 28 days for the STS-115 mission itself. So we get off the pad about 10 days earlier for the rescue than we do for the mission.
I'm talking, you look for tunnels for January. Can you speed it up? You're saying about 10 days? Is that what you're saying? Or any certain things that you can't?
We can probably get out of the OPF faster than July 25th, but that's a very unusual case you're proposing. I can't even go down
If you're talking about a crew needing to be rescued that's not at the International Space Station, that would be a very dire circumstance indeed, and I don't think we have the capability to launch a rescue mission within the lifetime of a crippled shuttle independent of the International Space Station. Yes.
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 Okay. We're running a little short on time. Let's take one more question, then we'll have to wrap it up.
Wayne, with two quick ones, I'll try to squeeze in before you wrap. Can you look ahead to Flight 116 and how the tank stands for getting 115 off the ground with a launch on need mission? You said earlier, I guess you had to take a week out of that flow or something to make that happen. And to go back to the probability thing, I'm not trying to beat that because I don't understand probabilities either, but did you guys do that this time and that's not something you want to present to us, or did you not make one of those matrices that categorizes where these threat levels are?
Well, okay, let me be real clear. We did not baseline. As a matter of fact, we sent the guys back to do quite a bit of work on the matrix. So it's not ready for us to sign off, much less release today. We did come to a really good understanding, but there are a number of things that they needed to do. One of the things that we wanted them to do was to show the worst case on this threat. And they had broken every potential hazard into how does it affect the wing leading edge RCC, how does it affect average or acreage tile, how does it affect the special tile that we have around the door seals. Well, they said, okay, we don't need 3 different X's, if you want to think about it on this matrix. We want one at the worst, what the worst effect is. So they've got to go do that. We had 3 or 4 other, I would call smaller organizational kind of things that we want to do differently. So it is not ready for sign-off. They are going to come back in about 2 weeks to our program control board for what we call baselining of that hazard report. At that time, it's it's in the public venue, and we say this is what we got. And your other question? Oh, 116 in the tank. Yes, we do. Before the accident, tank production was never a pacing factor in shuttle flights. I mean, the tanks were rolling out of the assembly line in plenty of time. We were always more concerned about getting the orbiters turned around or other things as pacing item in the launch rate. Following the accident and a better understanding of how critical the foam is and the amount of hand touch labor that has got to go into making that foam right so that it stays on that tank as best as possible, has made the external tank the pacing item, quite frankly, in our launch rate. So we are continuing to look at the processes down at Michoud to see how we might streamline them. We clearly, the pendulum is going all the way over to taking the maximum amount of care on every little thing. Some of the questions we have to ask are there some areas on the tank, perhaps on the side away from the orbiter, where we don't have to take quite so much care. It's not that you don't want to do a sloppy job by any stretch of the imagination, but perhaps does not require the length of time that we're putting in on the side that faces the orbiter. So we are right now pressed to get that 3rd tank delivered to the schedule. We have about a week that we need to take out of their proposed delivery schedule, and the folks are looking very hard at what they can do, either by reviewing some of the processes, reviewing some of the facility work that's going on around the tanks, or bringing in more people to help. So there's a number of ways to get back that week or so before December. And we've got a good management challenge in place to try to make that happen. But there is going to be a management challenge, and quite frankly, tank production is going to be the pacing item for shuttle launches through the end of the program. So we're going to continue to give a lot. They went from being probably operating in obscurity is not the right word, but close to that, to being in the limelight every day. And I think most of the external tank people would tell you they preferred the obscurity. But they are definitely in the spotlight, and we visit with them very frequently. And you know, I'm very proud of what they're doing, because they are working with materials that were never intended to be structurally sound at 4 to 6 times the speed of sound, and they're making it work, and that is just an amazing thing.
Okay, we'll have to make that the last question, and as always, thank you for your participation. Thanks.
Good afternoon, and welcome to the pre-flight briefing for the STS-121 crew. Today we're going to have some short introductions and comments from the crew, and then we'll go to the Q&A session. I'd like to begin by introducing the commander, U.S. Air Force Colonel Steve Lindsay, who's a graduate of the Air Force Academy and has a graduate degree from the Air Force Institute of Technology. Of course, he's an Air Force pilot and instructor pilot, and also a test pilot. He's logged over 5,000 hours on some 50-plus aircraft. He entered the astronaut corps in 1995 and went on to intensive initial training and then technical assignments before he started taking his shuttle missions. He's flown 3 times now. The first mission is STS-87 in 1997 as a pilot, and then also as a pilot in STS-95 in 1998, and then as commander on STS-104 in the year 2001. And with that, I'd like to hand it over to Steve to begin introducing the rest of the crew.
All right. Thanks, Doug. Well, it's good to be here today. For us, this press conference and the work we're doing today represents a milestone, which means we're just a few weeks from flight. It's been a long road for us, a couple of years of training for a lot of us, and a little less than that for some of the other ones. So it's great to be back here getting ready to fly. Indications are that the vehicle is in good shape, and we've passed a lot of milestones. We still have several milestones to go. But things are looking good for July, and I'm actually very optimistic about making a July launch window. So we're excited to be here. Happy to take your questions. What I'd like to do is we'll just go down in turn and introduce each other, a little bit about what each person is doing on the mission just briefly, and then hopefully have enough time for all of your questions. Next to me, Mark Kelly is a pilot on the mission. This is going to be Mark's second flight. He flew a mission in 2001 to the space station, also as pilot. Mark's background, he's a graduate of the Merchant Marine Academy, and he was a Navy pilot and a test pilot. He flew Combat and Desert Storm 1 in A6s, then he flew F-18s and flew both of those airplanes as an instructor pilot and a test pilot. He came here in the class right after mine and has been here just about 1 year less than I have. And on the flight, Mark's role are varied besides the normal piloting duties. Basically, the pilot and the commander can swap duties, and we're cross-trained to do each other's jobs. Probably Mark's biggest job on orbit is going to be, he's directing the 3 spacewalks, or the 2 planned and 1 unplanned spacewalks we have scheduled on the flight. And as a director of that, he's inside. He works with our 2 EVA spacewalking crew members, directing them in their activities and their tasks, making sure they stay on timeline, and we get through all the steps safely and expeditiously. And that's his probably biggest role. He's also involved in robotics, all of the systems on the orbiter, a bunch of space station work, and just about everything else you can think of. So over to Mark. Morning. It's good to be here today. Thanks for the introduction. I'm going to introduce Mike. Mike's a colonel in the U.S. Air Force Reserve. He's a native of Texas and a graduate of Texas A&M University. So he gets the historical distinction of being the first Aggie to go into space. And hopefully there'll be many others, right? So Mike's from South Texas in the Valley, as he calls it, down near Harlingen, somewhere. I don't venture down there very often. But he's a flight test engineer, like I said, in the Air Force. Had an Air Force career before coming here as a engineer at NASA, and then he was selected in the class behind mine, the class of A98. We've got 3 rookies on this flight. Mike's one of them. Mike also gets a really neat opportunity, and I'm jealous. He gets to do 3 spacewalks as our EV2. They'll be outside the space shuttle and space station for about 7 hours at a time on 3 different occasions, spaced about 2 days apart. So that's going to be interesting to watch him. He's been doing great in the pool, and I'm looking forward to seeing how he does on the real day. So over to you, Mike.
Thanks, Mark. It's been quite an adventure getting here today. Honored to introduce Lisa Nowak. She's our MS2. She serves as a flight engineer on the flight deck, riding herd over our commander and pilot up front, cracking the whip kind of in the jump seat between them. She's also one of our lead robotics operators during the mission. Lisa's a graduate of the Naval Academy. She served operationally as an electronic countermeasures officer in electronic versions of the A7 and A3 aircraft. Did flight tests later in the EA-6B and F-18 aircraft. She has been selected by the Navy for promotion to captain. She's also a member of the 96 class, as Mark mentioned, along with Mark. And like me, she's earning her astronaut wings in this flight. I'm looking forward to it.
Thanks, Mike. And yes, I'm definitely looking forward to it. It's been a long wait. We've been here 10 years, Stephanie and I both waiting for our first flight, and we think this is going to be really fantastic, both accomplishing all our mission objectives and just have some fun, too. So, in addition to doing a lot of the robotics and things on the flight like that, Stephanie will be working with me. We're pretty much a robotics team for all the things that we do. Stephanie graduated from Harvard, Bachelor of Science, and later got a Master of Science from the University of Texas. So I kind of have to stay down below here, a friendly rivalry. We all got along great. Wish you might see a little bit of rivalry during the flight, too. Stephanie, before coming here, worked at the Jet Propulsion Lab in the Galileo spacecraft in the IT control group, and did a lot of great work there. But as I'm sure very excited to come here 10 years ago and start training. We've both done a lot of interesting jobs before being assigned this flight. But we will be doing, as we mentioned, a lot of robotics, and Stephanie has an additional very challenging job of managing all the transfer that's going on. We're taking up a lot of equipment and supplies, and she's got to keep track of all of that and keep track of all of us moving it. And we know that she's going to do a great job on that. And she's also sitting next to me during entry as we come back for landing at the end. Over to you, Stephanie.
Thank you, Lisa. Yes, I am looking very forward to this mission. It has been a long wait, but it's been worth the wait. And we're all looking forward to doing the job that we have set before us. I'd like to introduce Dr. Piers Sellers, who was born in the United Kingdom. He has degrees from the University of Edinburgh and Leeds University. Prior to his work here at the Johnson Space Center, he worked at the Goddard Space Flight Center, studying the interaction of the biosphere and the atmosphere. He was a classmate of mine, astronaut class in 1996. He flew previously on STS-121. He was a spacewalker on that mission and helped to outfit and activate the S1 truss. And on this mission, he will also be involved with the spacewalks. He's our lead spacewalker. And he also works very heavily with computers, setting up our computer network and many other tasks.
Computers are always heavy work. It's my privilege to introduce Mynheer Thomas Reiter, a European astronaut who we're going to take up to space station and drop off there for 6 months. Thomas is a very, very experienced crew member. He flew on Mir in '95, did 2 Russian spacewalks. He can do everything and do it in 4 languages. It's something to watch. And he will be doing 1 spacewalk in an American suit this time, so he will have done pretty much everything that an astronaut or a cosmonaut can get to do. Glad to have you aboard.
Thank you very much, Piers. I was just counting 4 languages. It's English, Russian, German, and probably the 4th one you were mentioning is talking to my boys, which sometimes requires some special terminology to make them do what I want. Steve asked me, as I'm the last one, to say a few words to you, to maybe add something about myself. I don't want to do that. I rather would like to take the opportunity and say first a few words about my crew. I joined them pretty late in their training. It was initially not very clear how I will actually get up to the space station, so eventually I was very glad and happy to join Steve's crew, and it was really a very cordial welcome. I fully feel included in this crew, integrated, and I'm really looking forward to flying with you guys. Let me also take the opportunity to introduce my backup for the station cruise. There's always a backup astronaut. He is not here on stage, he's over there. Leopold Eihard. He's like many of us, has a military flying background, test pilot. He has been to the Mir station in 97, Leo, is that correct? 98, and Leo is actually, as soon as I'm in space, hopefully I won't break an arm or so he has to do the mission. But as soon as we are in space, he will be preparing for the actually first long-term increment when our European module Columbus is on board. Thank you very much.
All right, excellent. Thank you very much. Now we'd like to open it up to questions, and please give your name and affiliation, and if you would, direct your question to a specific astronaut. And also try to understand that at this point we're not going to be able to do follow-ups. We have a big crowd here today, so we're going to try to do one question at a time. And let's go with Nancy here. First question.
Hi, I'm Nancy Helen from KHOU, and I was eavesdropping before this started, so I'll ask Steve the first question. You said, boy, these people out there look so serious. They need to lighten up. You did, I heard you. Never say anything in front of a reporter you don't want to repeat it. But what do you do to lighten up your crew, and when do you need it the most?
Well, it's important. We do a lot of intense training, and it happens for a long period of time. For our crew, we've been training nearly 2 years, and we've had a lot of changes and things like that. And you can't really train, 12-hour days every day for 2 years straight without keeping it kind of light. And everybody's really good about it. I'm really blessed because this crew, everybody is very, very dedicated, and everybody's a perfectionist. And most of my time is spent throttling them back rather than pushing them forward. It's a very unique environment. And so we're probably our own worst critics in training. And I think with some training team in the audience, they might tell you that. I know I'm certainly considered that. So it's important to stay light, so we stay light, and we're all good friends. We get together as families, and we're almost like a family. We are like a family, and so we keep things light and keep things humorous between us, and get to know each other, and it's really key to go and relax. There's no reason to train all tensed up because it doesn't help you. It usually hurts your performance, and the more relaxed we are and familiar we are with each other, the better performance we have.
Jim?
Yeah, Jim Ogre with NBC for Mr. Ryder. Would like to try to take advantage of your experience and tell us what were the things you worried about before your first long flight that you're not worried about now, and some things you didn't worry about then that now you're concerned about for your next long flight.
I think the most obvious thing you start thinking about earlier or later before the launch is how it is actually to live for a long time on a very confined space on board production station. And I actually expected that there might be phases where, there might be little thunderstorms, as it occasionally happens back home. And afterwards, everything is fine again. This never happened. So it was very nice, despite this tightness at the station, a very intense schedule we are going throughout this long time, 6 months. There was not a second of boredom. There was not a second where there was really friction between the crew members. And even when we came back, we still had subjects to talk about. I mean, not business, but just about life, the universe, and everything. So that was a very, very nice surprise. Things that I did not expect to happen, which actually happened, maybe a little bit the off-nominals that can happen on such a complex system as a space station is. But I think this is again a proof for why we send people into orbit. We had a lot of failures that we never saw during our training sessions, and some of them we could just solve by improvising, by using the tools that we had available. And for me, this was actually a very good example and a very good experience that there is no technical system that can replace humans, and I don't think it will be in the near future.
Thanks. Irene Klotz with Reuters for the Commander. Where did the astronaut office weigh in on the ice frost ramp decision? I realize everybody's kind of come to terms, but just initially, what was your all's take on how that discussion was going?
Well, we have representation at all the boards that those decisions are made at. So we've been involved in the ice frost ramp discussion as well as all the other external tank discussions. And the issue, for those of you who aren't familiar, is the ice frost ramp and whether or not to. I assume you're asking whether or not to replace them with new ones or fly with the existing versions, and that decision that was made a little while ago on that. So we looked at the information and recognizing that we'd already changed out or removed the protuberance airload ramp, made probably the biggest aerodynamic change that we've ever made on the external of the vehicle. And our office looked at it as well, and we also concluded that if doing that in addition to a new ice frost ramp, we just soon make one change, flight test it, and then go to the next change, knowing that we eventually need to improve those ice frost ramps. So we were involved in all that. As far as testing goes, we've tested the entire vehicle. We've been in the wind tunnel with portions of the vehicle. We can't put the entire shuttle, the external fuel tank, the solid rocket boosters, and the orbiter in a tunnel and run it from launch all the way up to orbit. There's just no facility on the ground that exists for that. So we've taken pieces of the shuttle and we've done all the testing we possibly can to iron out the changes and determine that we have as safe as possible configuration. We feel we're at that point, and we've done everything we can on the ground, and we won't know exactly how everything will perform until we go flight test in orbit, and that's quite frankly where we think we are, and we think it's time to go flight test. So we were heavily involved as an office. I was heavily involved. Our crew was heavily involved and informed of the decisions going on and the process going on. We had our own folks in the office that are experts in those areas also participating in that decision.
Okay, next Todd Halverson of Florida Today for Mike Fossum. I'm wondering if you could give us your thoughts about bouncing on the boom and the safety of that operation.
You bet, Todd. Glad to. We've been working this test objective to test the stability of the boom or the orbiter boom sensing system, OBSS and NASA speak. The 114 proved its stability as a sensor platform to go out and do close-in inspections of the leading edge and underbelly of the shuttle. The next part of the question is will it hold crew members stable enough outside to actually affect a repair if one were to be needed. And so we've put a lot of work into that. We've tested it on an air-bearing floor, what we call a 3-degree of freedom simulation. We've had a larger pneumatic system we call the 6-degree of freedom simulation. We've done virtual reality. And all of the modeling and analysis we've been able to do indicates, a certain level of stability, but we still have to get out there and get the human in the loop with the whole bullet system. Safety-wise, no concerns. It'll be an eye-opener being at the waving end of about 100 feet of robotic arm and boom, way out away from the shuttle, out of the payload bay. But there's really, I don't believe there's a real safety concern about that. We're well within margins. We need to go see not so much a safety test as a stability test, and we'll do some of that in the open air, where we're putting in motions and measuring the response. And we'll go in close to the piece of the truss on the space station, something that's nice and solid, and we'll interface against that. I'll be pushing on it as if I'm doing simulated repair activities, just to verify that it holds us stable enough, and we'll evaluate that. We can't test the full range of possible configurations and dynamics, but we've got a good representative set in a nice, safe, controlled, disciplined manner. And so we're looking forward to doing that little bit of flight test quite a bit.
Bill Harwood with CBS. I'll ask this for Dr. Stonzo. I guess I could ask it to anybody, but we've all been talking about foam. We've been concentrating on that. You guys have, and it's certainly us talking about it for a long time. And we're listening to Wayne Hale talk about 0.2 of a pound of foam from an ice frost ramp is the most they expect. And I keep thinking to myself, and they've still got main engines on this thing, and a few other things. So, Dr. Stonzo, the question is, how do you look at risk
in the space shuttle today? I mean, what is it that you think about in terms of risk and what makes it acceptable to go fly? I mean, I'm assuming there's more things than foam that make you think when you come to a shuttle taking off. I mean, can you characterize the risk of this vehicle as a rider operator?
Only in very, coarse terms. I mean, if you look at the shuttle as a complete system, it's extremely complicated, millions of moving parts, the whole schmear. And after Columbia, an enormous amount of effort was dedicated to beating down all the areas of known threat. 2.5 years of effort. Then after 114, more effort. And we've now come to the point, I think, that the major villains out there, in terms of threat, have been dealt with, or at least thoroughly addressed, and we've driven those risks down as far as we can. Which leaves the things we don't know about, which are hopefully very few, we may never know about within the course of the program. There's no getting away from the fact that at the end of the day, there is some residual risk that you either characterize and you think you understand, and also some that you don't know about, and you just have to deal with that.
And back here to Alan. Yeah, go with him, please.
Alan Boyle with MSNBC. This would be for Steve or perhaps anyone else who had a strong thought on this. Some of the crew members on STS-114 were pretty frank about how upset they were over the foam loss during the last launch. How did you feel back then, and how has that opinion changed over the past year?
My honest reaction when I saw that piece of foam come off the protuberance airload ramp, I was surprised, because prior to that we hadn't had foam coming off that ramp. So it was surprising to me to see it happen. I was obviously disappointed that it happened, but I was surprised that it happened. There was a disappointment and there was a setback that we had to go deal with. Having said that, it's the nature of the business we're in. Pierce kind of alluded to it, but it's a dangerous business we're in. We think it's important for what we're doing. We pound those risks as flat as we possibly can, but there are unknowns out there. And I think that POW ramp, although we recognize because it is a sprayed-on piece of foam, it's a potential threat. Historically, we hadn't seen anything come off, so it was a surprise to me to see it come off, and I think we've done the right thing since then to deal with it. And when we get a setback like that, and we get them all the time in this business, and we have to go deal with it. We get over being upset about it, and we focus on fixing it. And I think that's what the program has done for the last year. We've looked at that. We made an early decision based on preliminary analysis. We can go fly without that ramp. And since then, they pulled that ramp off, got the tank ready, meanwhile engaging multiple wind tunnels all across the country to test it to the best of our ability to make sure we're absolutely sure that we're safe to fly without that ramp. And that's what's been going on in the last year with the POW ramp. So I was disappointed when it happened. I was impressed with the response that NASA has put into this in the last year. Next up, Mark.
Mark Carreau from the Houston Chronicle, and mine's for Thomas Ryder. What's your understanding of how long your mission's going to last? What are you sort of prepared for if you don't have a shuttle ride back? And if you don't have a shuttle ride back, what's your agreement with the Russians to ride back?
I think at the moment, as the next flights are planned, it's the intention to come back with 116, 12.8.1 in December. That would make this flight duration like 5 months. In case there would be a further delay to the beginning of next year, I just stay until 116 arrives. And then, of course, there is a decision point actually when Expedition 14 will return and Expedition 15 will arrive. I think the plan now is that in case 12.8.1 would be docking after this moment, I might be going down on the Soyuz instead, and that would make it like an 8-month mission. And in terms of how long can a mission endure, and how is the feeling towards it, I think if you are doing a long-term mission to the station, you always have to consider this situation. I think especially in the Russian space program on the Mir, they had a few cases where the cosmonauts had to stay longer than they expected, in a few cases even double the time they initially expected. even though this is much less likely nowadays, but this is always something you need to consider when you're going on a long-term mission. It might not be exactly 5 or 6 months, it could be a little bit more.
Tracy Watson, USA Today for the commander. You said that it's better to do only one major change at a time when you're doing test flight, but given that, are you comfortable with the risk of losing foam from the tank? We were told this morning that losing one of those ice frost ramps is quite likely. I'm wondering how that sits with you.
Well, it's good. I mean, it's a good question about the ice frost ramps. Interestingly enough, when we put the existing ice frost ramp in the wind tunnel in recent testing, the foam that came off that, the current design, they had a couple of pieces come off, but they were small enough that they were not a factor. So it actually passed that wind tunnel testing. I feel pretty good about that. But again, obviously, since we've had bigger pieces than that come off in the ice frost ramp in the past off the shuttle on a real flight, then there's something in our ground testing that we're not capturing. We don't know what that is. We've done the best we can on the ground. It's time to go flight test. In terms of flying with the existing ice frost ramp, there are a number of things that we have done additionally to help mitigate that risk, and we recognize that is a risk. The first thing we're doing on our flight, many of you may have heard of, is we're doing something called a low Q profile, and that's what it really means is when we approach supersonic speeds and we get the maximum force on the vehicle, we usually throttle the main engines down so that we can get through that heavier, thicker part of the atmosphere at a lower speed and do more of our accelerating once we're out of the atmosphere and there's no air loads on the vehicle. In the last 10 flights to 12 flights or so, we've been flying what's called a high Q profile. So we don't throttle down as much, we go faster, put more loads on the vehicle. Because our flight had some additional ascent performance. So what I mean is we were light enough that we could carry, say, an extra 1,500 pounds to orbit. If we just gave up about 1,000 pounds of that excess performance, then we could throttle down sooner, stay throttled down longer, and then throttle back up later, which would reduce the loads on the tank by, and don't quote me exactly on this, but somewhere around 7 to 10%. So imagine what it's like if you roll down the window on your car and you're going, say, 40 miles an hour and you stick your hand out the window, you're going to get a certain force on your hand. If you then accelerate to 60 miles an hour and you stick your hand out the window, you can tell there's a big difference. So doing this lower dynamic pressure, low Q, is essentially, instead of going down at 60 miles an hour, you're going down more like at 40. So there's less force on the tank, which buys a little bit more margin to deal with the uncertainties in the ice frost ramp. Additionally, we're going to have cameras all over the vehicle, inside and outside the camera, or outside the vehicle, as well as ground station. We have radar tracking of airplanes in the air looking at us, and we're going to capture all that data going up. Once we get up there on orbit, we're going to separate the tank. We have external tank cameras, just like STS-114 did. It's going to image the tank, and of course then we're going to do inspections. So if we have a problem with an ice frost ramp, we're going to know about it. And if for some reason, and very unlikely event, that it hits the orbiter and does damage, and we need to do something about that damage, we have limited repair capabilities. And as a final last resort, we also have the CSCS, or the safe haven capability, where we'd stay on station and wait for another vehicle to come get us. So we have a number of ways to mitigate this risk. Some are certified, some are not certified. So with all of that information, we feel pretty comfortable flying as we are with the existing ice frost ramp design. And as I said before, I supported the decision that the program made in keeping them the same.
Ryan Horsgar from KPRC-TV. My question is for Stephanie. How do you prepare yourself mentally for what basically is a test flight?
Well, we have been training probably for about 2 years now, and a part of the intent of training is to go over and over again all of the procedures and all of our activities so that we're very familiar. And there are some new things that we're trying since we are a test flight, but really I don't see the mental preparation to be any different. We have a very talented training team, and they go over every detail with us, and so that helps in the preparation both mentally and physically. And so I feel that we're prepared and ready to go.
All right, with that, we're going to close out questions here for now and go to NASA headquarters. We have one question there, and I believe we have 3 questions at Kennedy after that.
Yes, this is Seth Bornstein at AP. Also for Stephanie Wilson, as one of the younger crew members, you actually could see be still around in NASA when and if you go back to the moon. Can you tell me how, as one of the younger crew members, you view the NASA transition, especially as you go into your first shuttle flight? Do you see this more as an exciting time because you see what's going on in the future, or sort of a more nostalgic time because you see the shuttle starting to wind down?
Well, it is a period of mixed emotion. I mean, the shuttle has served us very well for the last 20 years. It's been a great vehicle. We've done a lot of great missions with it. We've done a lot of science and a lot of research and a lot of deployment of satellites and payloads, and so it has served us very well. However, low Earth orbit is only one destination in the wide, vast universe that we have, and so moving to our next phase and going back to the moon and onto Mars is certainly a big objective to have, and it's a good target to have for the next phase of our nation's space program. And so for that part, I'm very excited. I'll, of course, be very sad to see the retirement of the shuttle, but I'm looking very forward to continuing to explore space and seeing what our space program brings forward as we work on the Crew Exploration Vehicle and our Moon and Mars missions.
Thank you. And now we'll go to the Kennedy Space Center.
This is Pat Duggins with WMFE for Steve. Steve, the ice frost ramps and the PAL ramp is getting a lot of the attention as far as what could get in the way of a smooth liftoff for you all. Now that the flight readiness review is coming up, what are some of the other gotchas out there that really aren't being talked about very loudly?
Wow. You know, I've been kind of focused on those myself. So, I mean, the ice frost ramp, the external tank design has been a big part of it. But there's been a whole bunch of technical issues. The biggest one, again, is the ice frost ramp and the PAL ramp redesign. I'm trying to think of what other huge technical issues are. Most of the ones I know about have all been resolved. So there's a few other things out there. There was an issue with the solid rocket booster that they probably talked about earlier that we think we have resolved by changing out a box. There was an issue, the tin whisker issue was an issue from a while back. It's been resolved by us flying one new box and basically prioritizing our jets. And what the tin whisker issue was, the tin within inside of the box can grow, and the fear was that these whiskers that grow over time could break off and cause a short and cause an inadvertent firing of one of our jets while we're back to the space station, which would not be a good thing. And we've resolved that again by changing out a box, analyzing, concluding that it's pretty safe, that that's not going to happen. So we have a strategy for dealing with that. Another issue that has been out there is some window issues, some loads in some of our windows that weren't proof tested maybe at the right level. And to resolve that issue, they actually changed out some of the orbiter windows, which is actually quite common that happens. So those are the big ones that I know about. There's not a lot out there where our schedule is green, which means we're on schedule with some margin to make the early July window. So not a whole lot of other issues out there that I'm aware of at this time.
Good afternoon, Peter King with CBS News Radio, and this question's for Lisa. And earlier, and I know I'm going to butcher the quote, Wayne quoted John Young is saying, if you're not a little bit scared, you don't know what this is all about. So I'm wondering, after all the focus that's been on the ET, and of course there's been so much media attention on it as well, and other safety issues, how do you deal with the risks as you're a first-time flyer?
There's, of course, the risks are there as part of space flights, a risky business that we accept some of that in order to obtain some of those great goals of exploration and finding more about ourselves and the universe. On an individual level, we, of course, focus very hard on our training, and at each moment we have specific things to do, and Steve's been telling us how busy we'll be, and if we're not, he'll give us something to do. So it's very easy from that perspective to allow yourself not to worry about those big picture risks. I think maybe it's a little harder for everybody that's here that's been working with us and supporting us, both here at work and families, because they know all the risks too, and even though they support everything we're doing, they're not busy with the tasks every single minute like we are. So that's important to consider their thoughts and feelings, and it's a risky business, but we all of us believe that it's worth it.
This is Kevin Oliver with WFTV in Orlando. It seems like this flight has not gotten nearly as much attention as the last mission. I was wondering for any of you, do you feel like you're flying in the shadow of the last mission, and do you believe that your mission deserves just as much attention as the last one?
Anybody want to answer that? I'll answer for me. It's been really nice. You know, it's an important mission. We've been working very hard within NASA. We've gotten plenty of attention, as much as we need to focus on our mission and do a good job. And it's interesting with this crew especially, I don't have anybody on this crew that really seeks that anyway, and that's not why any of us are here. We're not here for the attention. Within our office even, it's not about a popularity contest about who gets the most attention. No crew ever feels that way. We're excited to be a part of this. We recognize that we happen to be a visible part of this, but it takes thousands and thousands of people from places all over the country, and quite frankly, all over the world in the nature of the international business we're in today, to get this done. And we may be visible, but it's all these folks that have helped us out here and at Kennedy Space Center and all the other centers is what makes this possible. And they're the ones that are the real heroes in this thing, and they're the ones that are making this happen. We just happen to be in the limelight. So we're not in it for the limelight. We're in it to accomplish the objectives and do the very best job we can.
Many times Steve has said that we are better looking than 114. So it has been hard to understand.
Well, with that, we'd like to come back here to JSC, and go ahead, Tom.
Which one of you is better looking than
I think?
Just collectively? Oh, okay.
Well, we know which two in here are better looking than the rest of us. It's not me.
A question for Thomas Ryder. To spend 5 to 6 months in space, you alluded to how you'd be in rather tight confines, but I think many of us wonder, how in the world do you plan to be away from your family for that long? How do you plan to pass the time for that long? How do you not strangle your fellow cosmonaut or astronaut for that long? But how do you plan to be away from your family that long? What do you prepare for?
Well, first of all, I think the communication means have significantly improved since near times. In my last mission, there was a possibility to talk to the family once every 2 weeks, and then every other week we had a video conference. My family at that time was living in Moscow, and they had to come to the control center in Moscow to talk to us, and then all the families were together. Now it's much better. We have IP phone up there, so whenever we have a few minutes time and we have a satellite link, we can call down to our family, to our friends. I think that is already a big step forward, and that gives you the feeling that you are not that far away. And of course, the video conference now is done in a way that you can talk to your family also at home, see them, they can see you. I think this is already a huge step forward. Other than that, yes, it is a burden also for the family, but if you just look around to other professions, I think it's not that unique. Just think about those people who are going to sea, are on long trips in other ways. In our neighborhood, there are people that are very often on business trips. And I mean, just the fact that we are probably there in a little bit more exposed location doesn't change the situation for the family that we are separated too much, or it's not too much different from the cases I just mentioned. Of course, yes, if you have children, especially young children, it's something that always catches your attention, what you could talk to them in the meantime, help them in school or growing up. But I think half a year is still not too long to look towards the end of the mission and then concentrate on the time when you can be back with your family and give them all a big hug again.
Very good. Next. Horst Rademacher, Frankfurter Allgemeine Zeitung in Germany, for Thomas Ryder. You'll be the first astronaut to come back to the space station to make a full complement of 3 space flyers there, and you'll be the first European astronaut for a long-term mission. What's your goal in terms of what you can do for ESA and what you can do to bring the European component more into prominence on the space station?
I think the first point you mentioned, that we are returning to a crew of 3, is of course a significant one. With 3 persons on orbit, we can definitely increase the scientific output. Everybody understands we are still in the assembly phase, so the station cannot be considered to be in a nominal operating state as it will be when assembly has finished. But we will definitely be able, with 3 persons on board, to increase the scientific output. Secondly, one of my main duties during my stay is to perform a quite comprehensive scientific program for the European Space Agency. 19 experiments in total from all different areas: life science, physics, biology. I will be also involved in a couple of the NASA experiments, and for the rest of the time I will support my colleagues Pavel Vinogradov and Jeff Williams in maintaining the station, keep it running, and to fulfill its function as a multidisciplinary laboratory. And I think in this role it is quite important from the view of the European Space Agency to have this opportunity to prepare when Columbus comes up. It is a very complex process, not only to get these systems technically working, flying again. It is also a quite complex process of preparing the daily timelines, of organizing the work up there. And I think it is a great opportunity for ESA to warm up with all these processes that are necessary to do that, and in this way get prepared as soon as our module has been docked, which at the moment I think is envisaged for the end of next year. They can right away begin with the nominal operation of the Columbus module.
All right, thank you. And we have time for one last question here.
My question is for Dr. Sellers, Ian Sherwood from the BBC. How difficult is it for your family to go up on a mission like this after the disaster in 2003, for them to sort of deal with you going up on a mission post the disaster?
It's more difficult, obviously, but no, they've been part of the business too for 10 years, and so they know a lot about it. And we spent a lot of time talking about the sources of risk and what we've done to deal with them. So I think, like Lisa was saying, it's probably tougher in many ways for the families than it is for us, but they're dealing with it remarkably well.
Der gebürtige Frankfurter, der in Neu-Isenburg sein Abitur machte, wird im Weltraum sogar Musik machen. Ist denn die Gitarre schon oben?
Die ist schon oben, und ich habe mich natürlich bei meinem Kollegen Jeff Williams auch schon erkundigt, ob die in gutem Zustand ist, ob noch alle Saiten funktionieren und ob vor allen Dingen noch Ersatzsaiten da sind, und das ist also der Fall.
Und Ihre Familie wird das zu Hause beobachten aus Deutschland, oder wo wird Ihre Familie sein, wenn Sie abheben?
Meine Familie wird den meisten Teil der Mission natürlich von Deutschland verfolgen. Beim Start wird sie natürlich mit in Florida sein und bei der Landung dann je nachdem entweder auch in Florida, wo auch immer das dann stattfinden wird.
Weil Sie sagen, je nachdem, wo es stattfinden wird. Theoretisch könnten Sie auch mit einer Soyuz, Sie sind ja ausgebildeter Kommandant, Sie dürfen ja die Soyuz sogar selbst fliegen, Sie könnten mit der Soyuz auch zurückkehren. Bedeutet das, dass Ihr Schalensitz schon startklar in einer Soyuz-Kapsel bereit läge oder dann bereitgestellt würde, falls es dazu kommen würde?
Den Sitz nehmen wir mit, und das ist eine meiner ersten Aktivitäten, nachdem wir angedockt haben, diesen Sitz in die Sojus zu verfrachten, weil erst dann bin ich sozusagen offizielles Mitglied der Stationsbesatzung. Das hat einfach auch Sicherheitsgründe. In dem Moment, wo dort oben irgendein Notfall eintreten würde, muss sichergestellt sein, dass alle Personen da auch in dieser Sojus einen Platz haben, und deshalb hängt das eben mit diesem Schalensitz zusammen.
Wird das Essen irgendwie auf Sie auch abgestimmt? Ich meine, Sie sind nun der erste Europäer, der erste Deutsche, der da oben ist.
Also die wesentlichen Teile des Essens werden von der amerikanischen, von der russischen Seite gestellt. Allerdings werden wir auch etwas europäisches Essen mit da oben haben, und ich hoffe natürlich, dass wir in Zukunft, da sich das internationale Raumstation nennt, diese Internationalität auch bei dem Speiseplan niederschlagen wird. Also dass Europa auch hier einen etwas größeren Anteil haben wird.
Wie stellen Sie sich denn jetzt auf den Schlafrhythmus um? Fangen Sie jetzt schon an, anders zu Bett zu gehen, damit Sie dann auf den Dienstrhythmus an Bord eingestimmt sind?
Nein, das beginnt ungefähr eine Woche vorm Start. Wir müssen da so einen sogenannten Sleep Shift machen für das Andocken. Wenn man dann allerdings dort oben ist an Bord der Station, läuft der Arbeitstag eigentlich nach mitteleuropäischer Zeit ab oder nach Greenwich Mean Time, also 2 Stunden Unterschied zur Zeit in Deutschland, und da ist eigentlich keine Umstellung erforderlich.
Was hat Sie denn, Sie sind ja der Europäer, der am längsten bisher überhaupt im Orbit war, und Sie haben ja die Erde schon ausreichend, obwohl Sie viel gearbeitet haben, beobachten können. Was ist das Beeindruckendste, die Umweltverschmutzung, die vielen Waldbrände oder einfach die Schönheit des blauen Planeten?
Sowohl als auch. Also man ist natürlich von der Schönheit unserer Erde überwältigt, die Möglichkeit, über ganze Kontinente zu schauen, in 90 Minuten einmal um unseren Planeten herumzufliegen. Auf der Nachtseite kann man ganz wunderbare Dinge entdecken. Eigentlich ist es so, dass jedes Mal, wenn man auf die Nachtseite kommt, man irgendwo ein Gewitter entdeckt. Man kann die Städte erleuchtet sehen, man kann Straßen erleuchtet sehen. Auf der Tagseite sieht man herrliche Dinge, aber man sieht natürlich auch die Effekte, die durch den Menschen verursacht wurden. Beispielsweise kann man über Südamerika mit bloßem Auge erkennen, die Schneisen, die in den Regenwald reingeschlagen werden. Man kann beispielsweise über Madagaskar erkennen, aufgrund der Erosion, wenn dort Regenfälle stattgefunden haben, wie der Boden in das Meer geschwemmt wird durch die Flüsse. Man sieht, wie wunderschön unsere Atmosphäre aussieht, wenn man gegen den Horizont schaut, und bekommt dann schon Bedenken, wie dünn diese Schicht eigentlich ist und wie verletzlich die aussieht.
Schritt für Schritt hat sich der zweifache Familienvater auf die vielen Arbeitsstunden in der Umlaufbahn vorbereitet. Seit 5 Jahren trainiert der ESA-Astronaut für die erste europäische Langzeitmission an Bord der ISS. Mit Hilfe von virtueller Realität arbeitet Thomas Reiter bereits im All. Der Blick auf die Raumstation stammt aus dem Rechner, ist aber für ihn so, als würde er selbst um die Raumstation schweben. Bald wird er sich bei 30.000 Stundenkilometern um die ISS hangeln, um dringende Reparaturarbeiten durchzuführen. In diesem 12 Meter tiefen Tauchbecken hat er sich darauf physisch vorbereitet. Hier drehte Hollywood übrigens 3 Tage lang den Science-Fiction-Film Armageddon. Ein Schwarm von Tauchern zeigt den Astronauten, wie sie die Raumstation montieren sollen. Mit Sprechfunk sind die Sternenmonteure mit den Ausbildern verbunden. Jeder Handgriff wird genau überwacht. Die Leichtigkeit im Wasser simuliert am ehesten das Gefühl der Schwerelosigkeit.
Der Anzug wird ja mit Bleigewichten genau so austachiert, dass der sozusagen im Wasser schwebt. Und der verhält sich eigentlich im Wasser schon sehr ähnlich wie dann tatsächlich im Weltraum.
Haben Sie denn im Weltraum dann einen maßgefertigten Anzug an?
Nicht ganz. Der Anzug wird aus einer Vielzahl von Teilen zusammengesetzt und wird natürlich auf einen abgestimmt. Der kann natürlich, wenn man dann mit dem Außenbordeinsatz fertig ist, auch für andere angepasst werden.
Und ist das jetzt hier Knochenarbeit, wenn wir jetzt hier runter gucken, wie die Kollegen arbeiten, ist das sehr, sehr anstrengend?
Das ist sehr anstrengend. Also wenn man hier 6 Stunden lang unter Wasser war und all diese Aufgaben bewältigt hat und kommt raus, ist man pitschnass geschwitzt und weiß, was man an dem Tag gearbeitet hat.
Haben Sie denn Angst vor kleinen Teilchen, die Sie vielleicht treffen könnten, wenn Sie da draußen arbeiten müssen? Also Meteoriten, Kleinstpartikel oder sowas?
Nein, also bisher ist sowas Gott sei Dank noch nicht passiert. Natürlich hat der Anzug gewisse Notfunktionen, wenn tatsächlich mal ein Leck entstehen sollte, dass man einen ausreichenden Notsauerstoffvorrat hat, um noch in die Luftschleuse zu kommen, um sich dann mit der Sauerstoffversorgung dort zu verbinden und die Schleusenoperation durchzuführen, dass man dann wieder im Inneren der Station ist.
Auf Thomas Reiter warten 700 Arbeitsstunden im All. Dort oben wird er ein gläserner Mensch sein, ständig überwacht von Houston, Moskau und dem künftigen Kontrollzentrum Oberpfaffenhofen. Im Mission Control Center kümmern sich im Schichtbetrieb Ärzte, Psychologen, Astronauten und Techniker um das Wohl der Menschen im All. Die stillgelegte Zentrale erinnert an die aufregenden Zeiten während der Apollo-Missionen.
Houston, wir haben ein Problem. Dieser Satz fiel hier im alten Missionszentrum in Houston. Aber das ist Geschichte. Nun schauen wir uns die neue Zentrale an. Von dort werden die Shuttles rund um die Uhr kontrolliert und überwacht.
10 Sekunden nach dem Abheben übernimmt Houston die Kontrolle über das Shuttle und überwacht außerdem ständig die Basis im Orbit. Je eine Überwachungszentrale kümmert sich um Raumschiff und Station. Ein Flugdirektor nimmt sich Zeit für uns. Carrie Körner ist 41 und nennt sich einen Stress-Junkie. 10 bis 12 Stunden am Tag dauert ihr Job. Ich bin für die technische Leitung verantwortlich. Wir sind vielleicht die größten Cheerleader der Astronauten, aber ich tröste sie bei Stress nicht. Bei Heimweh und dergleichen gibt's Psychologen. 160 Stunden wird sich Thomas Reiter in der Raumstation um wissenschaftliche Experimente kümmern.
Sie waren ja schon auf der Mir, jetzt auf der ISS. Freuen Sie sich drauf, dass es alles, oder sind Sie neugierig, ob das alles so ist, wie man es jetzt hier am Boden in diesen Mock-ups, in diesen Modellen hier in Houston ja schon eigentlich kennt? Oder ist es, meinen Sie, ist es genauso, wie es hier unten ist?
Ja, es wird sicherlich ein paar Unterschiede geben. Eins ist klar, diese Simulatoren, in denen wir uns befinden hier, die sind meistens etwas aufgeräumter, weil natürlich dort oben an Bord in diesen Jahren, in denen die Station betrieben wurde, sehr viel Ausrüstungsgegenstände hochgebracht wurden. Wir werden an Bord des Shuttles eine ganze Menge Ausrüstung mit hochbringen. Wir werden also 60 solche Pakete zusätzlich oben lassen, die irgendwo verstaut werden müssen. Also weiß ich, dass dort oben sehr viel Utensilien verstaut werden müssen, wo immer man paar Kubikzentimeter Platz findet. Aber ansonsten kann man sagen, im Vergleich zur Mir-Station ist die ISS heute etwas großzügiger. Man hat insgesamt gesehen doch ein bisschen mehr Platz und hat mit modernerer Technik zu tun.
Alle hoffen nun, dass auch die Technik der 22 Jahre alten Discovery mitspielt bei dem ehrgeizigen Raumfahrtprogramm.
Wenn Thomas Reiter mit dem Space Shuttle Discovery abheben wird, steht für die USA sehr viel auf dem Spiel, ihr Prestige. Denn noch eine Panne kann sich die Weltraumnation USA nicht leisten. Also die Sicherheit wird hier ganz, ganz groß geschrieben.
18 Mal sollen Space Shuttles noch von Cape Canaveral abheben. Wenn alles gut geht, dann wird eine neue Generation von Raumschiffen an den Start gehen. Zukunftsmusik.
Die Generation der Space Shuttle Flotte hat ausgedient. Bald werden hier neue Düsen und neue Raketen abheben von Cape Canaveral. Hier in dieser Halle werden wohl auch sie zusammengebaut. Auch darüber werden wir Sie auf dem Laufenden halten. Das war es für dieses Mal bei Forschung und Fliegen. Ich sage vielen Dank für Ihr Interesse. Wenn Sie mögen, bis zum nächsten Mal. Tschüss.